Hey, grade 10. So we're now moving on to lesson 5, unit 6. So we're getting near the end now. This lesson is a little bit shorter, so that's good. I mainly just want to go over each of the basically the effect it has on the function when we have the different parameters, a, k, d, and c in the equation. And this how to basically identify what the amplitude, period, phase shift, and vertical translation is just by giving the equation. And then we're also going to be looking at how to find the equation if we're given the graph or if we're given its properties. So big summary of the effect of transformations. We already talked about this. The amplitude we know is equal to the a value, the absolute value of a. The equation of the axis, we already know that. It's just simply the c value. The period, this is the one that throws people off. So I would definitely circle this because this is the one that tends to be a bit tricky. People tend to think it's exactly equal to the k value. It is not. We use the k value to help us find the period. So we take 360 degrees and divide by the k value, the absolute value of the k value. And again, it's 360 degrees because the period of the original sinusoidal function is 360 degrees. The phase shift is equal to d. And then, of course, we talked about the range. To find the range, we need to know what the maximum minimum points are, which kind of depends on the amplitude, the equation axis of the curve, and also if there is sorry, actually, no, we don't look at the reflection on the x-axis. We just focus on the amplitude and the equation of the axis itself. Okay, so let's look at a couple examples here. So let's, given the equation, state the amplitude, the period, the phase shift, and the equation of the axis of the curve. So let's look at the first one here. Well, the a value is clearly 1/3, so that means that my amplitude is definitely 1/3. My k value of 4 doesn't actually tell us what the period is, right? But it does help us to find the period. So we know that the period is going to be 360 degrees divided by 4, which is 90 degrees. So again, I always like to think of k value as speed, right? It tells you how much faster the sinusoidal function is moving. So if you have a k value of 4, that means you're moving 4 times as fast as you used to. So if you're moving 4 times as fast, that means that you're going to be completing your cycle in 1/4 of the time as before, right? You're completing it a lot faster there. So because of that, it's going to be, the period is going to get smaller, which means we divide by 4, and that gives us 90 degrees there. The 30 degrees right there is just our phase shift. That's pretty simple. And of course, our -2 just tells us that that's a vertical shift. Vertical shift of -2. And that obviously means that we have an equation of the axis of the curve. Equation of the axis that is going to be -2. Okay, so the equation of the axis of the curve is going to be -2 in that case. So again, just looking at the a, k, d, and c values, we can actually identify a lot of different properties of the sinusoidal function. So again, going through it here, 1/3 means the amplitude is 1/3. The k, we already said, it helps us to find the period, which is 90 degrees. D tells us that the phase shift is 90 degrees, which means that our sine graph begins at 30 degrees. And a c value of -2 just means that the equation of the axis of the curve is -2. So roughly, if you were to draw this graph, this would be a quick sketch. It doesn't have to be perfect. And it wasn't asked in the question, so I wouldn't worry about it. But if you're just curious, what does it actually look like? Just roughly speaking, it looks something like this. So we have -2 as our equation of the axis of the curve. So -2 is right there. Actually, I'll make this a little bit different. And I wouldn't necessarily make you graph something like this, just because I'm not a big fan of the numbers themselves. I would make it so that the a is an integer, just so it's a little easier to identify. So we have 1/3. So let's see here. So I would so that means if we're just adding 1/3 to this, it's going to be -1 point, or sorry, we could say -1 2/3. That's the max, and the minimum would be -2 and 1/3. So the graph kind of roughly looks like this. So you start with 30 degrees right here. And again, remember the sine function starts right at the equation axis of the curve, and then it goes up. So it's going to look something like this. Oops, let me just redo that. gonna look something like this. It's gonna go up like that. And because the period is 90 degrees instead of 360 degrees, that means it's going to end here at 90 degrees. And that means that the max and the min would happen would occur at different spots, right? So if you were to try to figure out where would the max, and again, this is where you would need your knowledge of the 4 quarters of a sinusoidal function. Let's say the question, this would be, by the way, a great multiple choice question here. I could ask you, maybe I wouldn't ask you to draw the graph, but I might ask you, where is the maximum going to be now, right? Now you could actually transform the graph, the key points to figure out where it would be, but I feel like it might be easier to simply take your period. Oh, by the way, I made a mistake here. I wrote 190 degrees. I meant 120 degrees. Sorry, that's what I meant to say. Because we're simply adding 90 degrees to 30 degrees there. So a good follow-up question to this, I think this would be a great follow-up question, would be, where's the maximum point going to be now in this new function? So the maximum point, you know that it's going to be in the next quarter after the equation of the axis of the curve. So if the equation of the axis of the curve is at -2, that means that one of the key points is -2, 30 degrees and -2. So then you think to yourself, okay, well, what's 1/4 of 90 degrees? Well, 1/4 of 90 degrees would be 22.5. So that means that your maximum would be at 30 degrees plus 22.5, which would be at 52.5 degrees, right? And again, how did I know it was 22.5? I simply took 90 degrees and divided by 4, because it's split up into the 4 quarters, not because of the a value of 4, just so you know, but because we talked about how that you can actually, your 5 key points can split the sine graph into 4 segments, right? And of course, if you wanted to know the minimum here, you could do the exact same thing. Simply take away 1/4 of the period from 120 degrees, right? And that would tell you where the minimum is going to occur. And of course, the maximum occurs at 52.5 degrees, but the maximum value is going to be -1 2/3, right? So you simply just add the amplitude to the equation of the axis of the curve. So again, I'm going a little bit ahead. I know the question didn't ask you to do that, but if the question did ask for more details, this is how you would find out where the maximum and the minimum points are. By the way, this would be a great multiple choice question I could give you. So you might want to read up on something like this, right? So how would you actually split up how would you identify the key points if you're given all the different parameters, right? So it's just a matter of you trying to identify, either you can do the transformation of the key points, you can definitely do that, that's totally fine, or you could identify what the quarters of your sine function is going to be. So hope that makes sense. This next example here, what we're doing is we're identifying, again, same thing, amplitude, the period, the phase shift, and then of course the equation of the axis of the curve. So we know the phase shift the amplitude is going to be the absolute value of -2. So again, we ignore the negative sign and we know that the amplitude is going to be +2. We know the K value is 1/2, which means that the period is going to be 360 degrees divided by 1/2, which means that it is 720 degrees. So again, when we divide by 1/2, we are simply multiplying by 2, right? That's another way of looking at it. And again, this makes sense because if we have a K value of 1/2, that means you're moving twice as slow as before, or you're going at half the speed. Think of it that way. So if you're going at half the speed, that means you're going to finish the cycle, but you're going to finish it in twice the time as before because you're going slower. So then that means you complete the cycle at 720 degrees instead of 360 degrees. Should make sense. The D value is simply going to be 120 degrees. So that means that because the D value is 120 degrees, that means your phase shift is 120 degrees. So your cosine function that would normally begin at 0 degrees, right? And remember, the first key point for the cosine function is 0 degrees and 1. So now your cosine function is actually going to start at 120 degrees instead of, 120 degrees to the left. Sorry, I made a mistake there. It's -120 degrees because again, it looks positive, it's actually negative. So it starts at -120 degrees. So you're moving it to the left. And the C value of 6 means that the equation of the axis of the curve is 6. So we can write that, if you want to write it as an equation, it's just going to be y is equal to 6. So when you're finding the equation, if you're getting the graph, again, you want to remember all these key pieces of information we given before. I'm not going to go over this, although you should already know this. The equation of the axis of the curve, you can easily find it by taking the maximum plus the minimum divided by 2. The amplitude, you can find the difference between the max and the min and divide by 2. You know how to find the maximum. If you're given the equation axis of the curve and the amplitude, you know that you can simply take your equation axis of the curve and you add the amplitude. You can find the minimum by taking your equation axis of the curve and subtracting the amplitude. You already know this as well. We talked about the range being, the range is basically going from your minimum point to your maximum point. So the last piece of information I want to go over, and this will be really important to you, how to find the period and how to find the k-value. So in the other examples, we were able to find the period by taking 360 degrees and dividing by the k-value. And because that's the case, I'll just explain to you what happens here. If I ever wanted you to find the k-value, what if it was the opposite way? What if I gave you a graph and you want to find the k-value? Well, luckily, it's actually pretty easy to isolate for the k-value. You cross multiply here. So when I cross multiply, I end up getting the period multiplied by the absolute value of k is equal to 360 degrees. So if I want to get the k value by itself, I simply divide by the period on both sides, and look what happens here. We end up getting that the k value is equal to 360 degrees divided by the period. So that's another easy way that we can find the k value as well. Again, this only gives you the absolute value of k, but for most of the time, we're going to be focusing on the k value being positive anyways. So it's not really going to be too much of an issue anyways. Okay, let's look at an example here. So if you're given this graph here, and actually we did this example already, so you'll note that we actually had pretty much the exact same answers as before. Nothing's really going to change. The only difference is that in this question, I'm asking you to find the equation that models the height above the pool, h at t, over time. So one extra thing, I just want you to find out what the equation is. So if you recall, I'm going to skip a couple parts here because we already did this. The equation of the axis of the curve, the EOA, is going to be 2. And we talked about that because the maximum point is 2.4, the minimum point is 1.6. So if you want to find the equation of the axis of the curve, it's just the average of the two, which is 2. Pretty simple. The amplitude, we talked about that, is just going to be the distance from the equation of the axis of the curve to the max and the equation of the axis of the curve to the minimum. And that is 2 in both cases. So the amplitude was 2. So we have our amplitude, we have our equation of the axis of the curve. Our period was 3, if you recall, simply the distance, how long each cycle lasts, which was 3 seconds. So we can see here that the period is 3. So how can we use that to find the equation? Well, let's piece it all together. Pretty simple here. The a value is going to be 0.4. Now notice that this is still going to be positive. Why? Because there was no reflection on the x-axis. If the graph had gone like this, in a different direction, then that would mean that the a value would be negative. But we'll talk a little bit more about that in the next lesson. In this lesson, I just wanted to start introducing how to start doing the equation, okay? How to start finding the equation. The c value here, oops, I'll go back here. The c value is simply going to be the equation of the axis of the curve, which is 2, and we already found that. Pretty simple. And of course, the k value, remember, we had to take 360 degrees and we divide by 3, and that gives us 120. So putting that all together, we have an a value of 0.4, a c value of 2, and a k value of 120 degrees. So that means that our equation is 0.4 sine of 120t plus 2. Now notice that there is no d value. And why is there no d value? Well, remember the sine function starts at 0 degrees. And notice that this graph is kind of like the sine function, and it starts at 0 degrees. And again, why do we know that it starts right at 0 degrees for the sine function? Well, the sine function starts at the equation of the axis of the curve. So it makes sense that the phase shift would actually be 0. Again, this lesson, to be quite honest with you, this lesson and lesson 6 are very much together. So I wouldn't, if you're kind of having a hard time with the phase shift, don't stress about that. I think it will make more sense when we look at lesson 6. So if that's the only part you're not understanding, just be patient a little bit. It will make more sense in lesson 6, okay? Let's look at another example here. So find the equation of the graph given. Well, we can clearly see here, let's start with the easy stuff. The equation of the axis of the curve is going to be 4. And we can see that because the maximum is 6, the minimum is 2. So doing a little bit of math, we know that the average, the number right in between them, is 4. So the equation of the axis of the curve is 4. is 2, and sorry, the equation axis of the curve is 4. The amplitude, going back to this graph here, is simply going to be half the distance between the maximum and the minimum. So sorry, I can't find trying to get the marker going. Sorry, technical issues here. Okay. There we go. Just trying to get the marker going here. Okay, there we go. So we can see here that the amplitude in our case is simply going to be 2, because if our equation of the axis of the curve is 4, then our amplitude is just the distance from the equation of the axis of the curve to the max, which is 2, and or in the equation that the distance from the equation of the axis of the curve to the minimum, which is 2. Or we could also look at our amplitude as simply being half the distance between the max and the min. So half the distance, the distance between the max and the min is 4, so obviously half of that is 2. So the amplitude is 2. So we got that. Amplitude is certainly 2, and of course you could use the equation to figure to justify your answer as well, or just to verify that it's correct. The equation axis of the curve is 4. We already talked about that. The period. So if we look back at this graph here, we can see here that the period actually goes from 0 degrees to 360 degrees. So because it's going from 0 degrees to 360 degrees, roughly, because it kind of ends right there a little bit late there, that means that the period is 360 degrees. Perfect. So far, so good. So now, piecing all this together, we know that since the period is 360 degrees, then K is 360 degrees divided by 360 degrees, which is 1. Now, notice that I didn't put the absolute value because, again, like I said, most of the time we'll assume that K is positive anyways. And the phase shift is 0 degrees because the sine function starts at 0 degrees. And again, how do we know that? Well, because it starts at the equation, because the graph started at the equation of the axis of the curve, which is what the sine function does, then we know the phase shift is 0 degrees. So then we piece this all together. That means the equation of the graph is 2 sine x plus 4. And that's all we have to do there. So we simply put the a value of 2 and the c value of 4 there. So actually notice that this graph basically is affecting the y, it doesn't affect the x at all. Let's look at another example. So find the equation of this graph here. So what do we start with first? Well, I personally like to start with finding the equation of the axis of the curve and the amplitude, because those are a lot easier, right? So we know the minimum point is 1. We know the maximum point is 9. So that means that the equation of the axis of the curve, again, you can do this in your head, would be right in between 1 and 9. That means it's going to be 5. So the EOA, equation of the axis of the curve, is 5. So if I know that the equation of the axis of the curve is 5, how can I find the amplitude? Well, the amplitude would be pretty easy. You simply find the distance from the equation of the axis of the curve to the max, or the equation of the axis of the curve to the minimum. So in both cases, it's 4, which should be the same. Or you could take the distance between the max and min and then divide by 2. And again, for both of these examples, you can just use the formula as well, right? I like to use the formula and verify with the graph both ways, right? Just to verify that I'm on the right track here. But the formula is a great way to just check if you're doing it correctly. What else do I need to know here? Well, I know that for the period, sorry, for the K value, I need to know the period. So one cycle that I have here, and I want to pick a cycle that's easy. I can see here that this cycle would probably be the best one to look at. So going from 0 to 10 on the x-axis here. So that means that the period is 10. So if the period is 10, then I can easily find the K value. It's just going to be 360 degrees divided by 10. And that's going to give me my K value. Now, notice that the graph, if we're looking, it depends what equation you want to model it with. If I decide to model it with the cosine graph, we can actually model it with the sine or the cosine graph. But if I decided to model it with the cosine graph here, I would actually do negative cosine, because remember, positive cosine. So if there's no reflection on the x-axis, the graph goes from the max down to the minimum and back up to the max. Notice that this orange cycle here is doing the opposite. It's going from the minimum to the max to the minimum. So because it's going in a different order than we would expect, it's a reflection on the x-axis, right? So technically, it would make sense to transform the cosine function, but you want to note that there is a reflection on the x-axis. Again, this is just going over what we talked about. The amplitude is 4. The equation of the axis of the curve is 5. The period is 10 degrees, or 10 in this case. And we just take 360 degrees divided by 10 degrees, and that gives us 36. So the phase shift is 0 if we decide to use the negative cosine function, right? And again, notice that it's the negative cosine function that starts at 0, right? If we decided to go with the positive cosine function, that's a different story, and we can actually talk about that. And again, you can actually transform this using the sine function, and we'll kind of discuss that as well. So I don't want to go into too much detail yet, but essentially, because we decided to use the negative cosine here, we need to make sure that the a value is negative. However, if I had chosen to use positive cosine, the only difference is that you would have to make sure that your graph starts at positive 5 instead of starting at 0. And that means that your phase shift would actually be 5, right? You would have a phase shift of 5. If I decide to look at the sine function, if I decided to model it with the sine function, I would have to make sure that it gets translated 2.5 units to the right. And again, why is it 2.5? Well, again, this is where I use my knowledge about the 4 segments of a sinusoidal function. I know that halfway between the maximum and the minimum is the equation that acts as a curve. And we know that that's going to happen at halfway between 0 and 5, which is 2.5. Or I could actually technically look at this one right here at a phase shift of 7.5, but then I would have to use negative sign. Again, don't want to get into that yet, because that's actually something we're going to cover in the next lesson. I just decided to kind of break it down a little bit for you. So for now, it seems like the most logical choice would be to look at negative cosine. So the only difference is that you have to put a negative sign in front of the a instead, right? Everything else stays exactly the same. So it's negative 4 sine x, sine of 36x plus 5. And that is your sinusoidal function. So I hope that makes sense so far. So again, all you're doing is identifying the amplitude, identifying the equation of the axis of the curve. Again, the amplitude is the a value. The equation of the axis of the curve is your c value. You already know how to find the k value. We 360 divided by whatever the period is. And the only thing that's a little bit difficult so far is the phase shift. That tends to throw people off. Again, we're going to talk about the phase shift more in the next lesson. I think it'll make a bit more sense. So let's go to our next part. Finding the equation if you're given the properties. So what if you're not given a graph and you're actually just given a description? This is where it gets a little bit tricky, because this tends to throw people off in terms of how to start it. So let's read the description here. So we're told that we have a sinusoidal function that has an amplitude of 2 units, a period of 3. Find the equation of the sinusoidal function by transforming the cosine function. So what do we do in this case? Okay, let's go step by step here. So we know that the amplitude is 2 units. So again, there actually are, before we even start, there's actually multiple ways that we can find the answer, but I'm going to focus our attention on transforming the cosine function, and there's a reason for this. I want to focus on the cosine function instead of the sine function that occurs at 0, technically 0 degrees and 3. So because it's 0 degrees and 3, and that means that we reach our maximum point right at the beginning of the cycle, it makes more sense to use the cosine graph, because again, if you recall, the cosine graph starts at a maximum, goes to minimum, and then ends at a maximum. So it makes more sense to transform the cosine function there. Again, we'll talk a little bit more about how to transform a sine function versus a cosine function and all those different technicalities of it. But for now, let's just focus on the fact that we're going to transform cosine function. So what do we know? Well, we know the amplitude is 2. So indirectly, we already know the a value. A value is 2. Again, technically, the a value could be negative, but I'm telling you right now, because we started at a maximum, not a minimum, your a value is positive. What about your period? Well, our period is going to be 360 degrees divided by whatever the period is. Sorry, I meant to say, what is the k value? So then we simply take 360 degrees divided by the period. So 360 degrees divided by 180 degrees gives us 2. So our k value is 2. Okay, done. So we have 2 parts already. So what else do we know? Well, we know the maximum is at 3, and we know the amplitude is 2. So again, if you draw a graph, I think this might actually help you out. So if we know that we start at a maximum of 3, 0 and 3, and then we know it has a period of 180 degrees, like that. So we start at 0 degrees here and 180 degrees. Then we know that the graph is going to look something like that. And again, the amplitude we're told is 2. So if we know the amplitude is 2, that means that the equation of the axis of the curve is going to be at 1. And how do I know it's going to be at 1? Well, because the amplitude is just the distance from the maximum to the equation of the axis of the curve. So because the distance between them is 2, then doing a little bit of math, we know that we just subtract 2 from the maximum to find the equation of the axis of the curve. And of course, now that we know what the equation of the axis of the curve is, we know it's 1, then really we have the whole entire equation. We also know, by the way, not that we need to know this in this case, but we could also find the minimum by simply taking the equation of the axis of the curve and subtracting off the amplitude. So we subtract off the amplitude, which is 2 there. So we can clearly see here that the equation of the axis of the curve is 1. And again, you could technically use the formula that I gave you. I gave you that the maximum is c plus a, or c, the equation of the axis of the curve plus the amplitude. But we know that to find the equation of the axis, to find the equation of the axis of the curve, you simply would just rearrange for the c value. So you would take 3 minus 2, which gives you 1. Or you could draw a little sketch here, and I think you mostly would be able to figure out that the equation of the axis of the curve is 2. By the way, a good question, by the way, this would be a good little true or false question. Remember that amplitude is always positive. So the a value might be positive or negative, but the amplitude is always, always, always positive, right? Because really amplitude is just measuring the distance, half the distance between them. Just remember that, okay? Little hint, because you might see a question like that on your tests. Okay, last thing, because and again, we talked about this, because it starts at a maximum, then it makes sense that transforming the cosine function would be the easiest. And because it already starts at a maximum, the phase shift is just going to be 0 degrees. So you don't actually have to change anything. So putting this all together, we have an a value of 2, which is where this is coming from, a k value of 2 as well. So that means you put the 2 in front of the x, and then the c value is 1. So we just sub it into our equation, and we are fully done with the transformation there. So I'm hoping that kind of makes sense so far. All we're really doing is simply taking the transformations that we have in our general sine function, in our general transformation of sine function and cosine function, you're just changing all the parameters there. So for example, in the transformation of a sine function, we have a sine kx minus d plus c. So all we're doing is finding out what the a, k, d, and c values, and you're replacing them here. And of course, we do the same for the cosine function. And again, not all the parameters are used all the time, right? So in some cases, some of the parameters are just going to be 0. So we could have a parameter of 0 here and a 0 there, which means you don't really change anything there. Or if you have a parameter of a is equal to 1 or k is equal to 1, then it also doesn't change the equation. But this is in general what all the transformations would look like, right? They always will have this form. So depending on whether you transform the sine function or the cosine function. So that is basically it for this lesson. Like I said, we're not done with this yet. Lesson 6 will be kind of a continuation of lesson 5. Lesson 5 is more kind of a bit of a warm-up, just kind of introducing the whole concept of replacing the parameters with the k value, which is found using the period, and also looking at your vertical shift, because that would be equal to your equation of the axis of the curve. So using all that information from a graph, just being able to identify what the parameters of the equation is. Okay, so that is basically what we covered in this lesson. Hopefully that made sense. A bit more detailed, but hopefully this first lesson made sense, and we can continue from there.